Hi, this is Snow. Now I'm going to see how to solve this problem. So a first non-repeating character in a string. Given an input stream of n characters consisting only of small case alphabet. So that means there is only 26 characters. The task is to find the first non-repeating character each time a character is inserted to the string. If no non-repeating element is found, print -1. Example, so flow in a stream. A goes to stream. First non-repeating element is A. A goes to stream, no non-repeating element. B goes to stream. First non-repeating element is B. C goes to stream. First non-repeating element is B. Okay. So do we need to keep a record of all the elements in the stream? I don't think so. We can modify this. We don't need to record everything in this stream. And so let's draw a stream. So first we put in an A, and then we put in an A again. And now A is gone. And then we put in B. And we put in C. This is our first non-repeating element. So if we put in B again, that means this one will cancel out the other one. And if we put in B again, and B is still okay. So if we put in B again, so there is already a B. So okay, we should not remove this. We should not cancel them out. We need to keep a record of what's already in there. So A, B, C. So B already in there, so does not change our non-repeating element. And C, okay, and B again. Still -1 because we don't have any non-repeating element. Okay, how about we do it again, putting one by one. So first we put A because the stream is empty. And then we want to put another A, and we should check if A is already in the stream. So to look up, usually we use a dictionary to achieve a constant lookup time. So let's see, we have a dictionary, and A, since A is already in there, so we have this key and value. This value, we're going to keep a record of the repetition or the frequency. How many times have A appeared in this stream? So now it's 1. And we want to put in another A. We look up in the dictionary and the key is already exist. So okay, we also need to keep a variable that is our first non-repeating element. So let's call it result because this is what we're going to print out. So the first the result is -1 when it is empty, and when we put in A, it becomes A. And when we want to put in another A, it's already in the dictionary, so we change it back to -1 and we put this A in. And now we want to put in a B. Oh, sorry. I want a B. And is B already? Okay, so, oh, I forgot something. So we put another A in the stream and this should be changed to 2. And now we put in another, we put the first B in the stream. So let's check. Does B exist in the dictionary? No, it's not. So we can put it in the dictionary and keep a track of its frequency and put it into the stream. And now this becomes B. And next, if we want to put a C inside, we check is C in our dictionary. It's not, so we are going to create its key value pair and put it into the stream. And we will not update the result because B is still the first non-repeating element. And then if we want to put in B, another B, we check is B already in the dictionary? Yes, it is. So we need to change it to 2. And we put it in, and we need to change our results because this is 2, so it is already repeated. So we change it. And now what is our first non-repeating element? It becomes C. Becomes C. And how do we know it's C? So the first non-repeating, so we are looking from left to right. It used to be here. It used to be this B, but this B got repeated. So it's like we need to move to the next to find what's next in our repeating element. So we found C, and C is in our dictionary appeared only once. So we can say C is the non-repeating element. So let's see, we want to put another B in this. We look up B, and B is already in the dictionary, and it has its frequency is 2. So this means it cannot be our first non-repeating element anymore, so let's just ignore it and put it in. Should we still put it in or not at all? Oh, maybe we don't need to keep everything. First, we can have an A. So if A already in this dictionary, then we're going to pop out A. And now we want to put in a B. B is not in the dictionary, so we put B in. And next we put C in. And next we want to put a B. But B is already in the dictionary, so we're going to pop it out. And change our result. So say, so our result was B. So once we got another B, we should change our result. So it's if result equal to the next element in the stream, then we should remove that. Okay, we remove that. And now we want to find the first non-repeating element. We just check out what's still in the stream and pop and pick the first element. We want to pick the left from C, right? Okay, and next, if we have B again, we have saw that B has already been in the dictionary twice, so we don't do anything. If we have a C again, C is in the dictionary once, and that means we need to pop this out. Okay. And if we have a D, we just put in if the next thing, if D goes to the stream, that means D goes to the stream. And now the first non-repeating element is D. And if we have D again, so our dictionary will see that D has happened once. So D goes to the stream and D has already in this, so we're going to pop out this D. So is the D always on the left side of this string? Maybe not, because we can have, for example, we can have E, F, G, and G. So we want to pop out G, so we will pop it from the middle of the stream. So sometimes we need to pop something from the middle of the stream. That means we need a doubly linked list to remove something in a constant time. So let me draw an example. Here is a little bit a mess. So for example, first we put in A and then we put in another, how can I draw this? So what I mean is this E, F, G, F, E, F, G, I. So imagine we already have this non-repeating elements in the stream. So now we want to let G go into the stream, but G is already there. So we are going to pop this out. Otherwise, it will someday become our first non-repeating element. So we do need to remove something from the middle of the stream. Okay, so let me clean this up. So now I know that I do need a dictionary, but I also need a doubly linked list. Doubly linked list that we can remove from the middle. And this doubly linked list stores only the non-repeating elements. For example, E, J, F. So if G wants to go in, it cannot because G is repeated. So what we're going to do is we remove this G. So all the things left in the doubly linked list is non-repeating. And once we want to see what is our first non-repeating element, we just pop left of this doubly linked list. Okay, let me write my steps. So first, we need to check who wants to go in the stream. And if the stream is empty, we just put a new node in this. And if we put in a new node in this, we should also record it in our dictionary and its frequency so far. Okay, let me write the code. Okay, this is to run. Okay, right. So we are implementing something. Is it a class or a def? Okay, it is a class. not a class, just a def. Find first array. Do we need a node? Need a dictionary. And this dictionary's key is a character. So we want to map character to node. So for example, if we want to see G is already in the dictionary, then we want to pull out G. And to pull out G, we need to know where G is. So the data we store in our dictionary is the reference to the node. And the key is a character. Okay, so then I can try do this. How to put something in a stream. You need to get so the user is going to put in a character to the stream. So you should have maybe a class. I think maybe we need a class. So in the class, we will have a method is for the user to add in a character in the stream. Add in stream. Character. Now we should see if the stream is empty. Okay, we need to check, we need to have a stream with dummy node, dummy head and dummy tail. So we're going to add it in our init function. So this is going to be def init self. And dummy head. Okay, self. So this is self. dummy head is a new node. So we need to write another class node. In this node, it should have a value. The value is a character. So let's see, character. So that character is the character, and so that previous is none. So that next none. Okay, now we are going to construct a dummy node. For a dummy node, we the data should be none. So there's no character in this, only pointers and oh, and also a dummy tail. Because let me just write head and tail. So now we have an empty string with a dummy head and dummy tail. So now if we want to add something into the stream, if the stream's length is empty. So how can we check the stream of the length of the stream? The stream is empty means if self dot add. Okay, so okay, for the initialization we need to point this self dot head. So the stream, we check if the stream is empty. That means self dot head dot next is self dot tail. That means the stream has no real node in this, no like real character in this. Then we should add it to the stream. Oh, should write this next in stream. So then we can have a helper function to write how to add an element in the stream. Add and write. So we need a node. So we want to write this help function to help us add node at the end of the stream. So code is first we need to find what's already at the end of the stream. So last node equals node dot the tail, the previous. And then we add in the node. We can point the node next to the tail, and we point the previous to the last node. It could be the dummy hat, but it doesn't matter. The dummy hat has pointers. So, and then we should add the last node that next point to the south dot, the node. And the south, the tail, the previous point to the node. Okay, so now we can use this helper function. If self dot head and next equals self the tail, that means the string is empty, then we can add right. And we need a node. So that is a new node. And we need to make this new node. Yeah. And we add it in. Now it is in our stream. We also need to update our dictionary. So dictionary key is a character. Value is the frequency. Now it is 1. Okay, next. So this is one condition, that is if the stream is empty. If it's not empty, then we need to check whether the thing to be added is already in the dictionary. So else if check the card character in dictionary, we need to check. So if character is in the dictionary, then if its frequency is 1, we need to put it out. If its frequency is 2, it's already been put out, so it don't do anything. Okay, if the character in dictionary, we need to check the frequency. So put it out. I'm going to write another function to put it out. So here, let's say remove node. need to know the key of the node. So the key is actually the character in the node. So just say the character. Maybe just a node. Okay, to remove a node. So we have dummy nodes, so we don't need to worry about edge case. We can just have the node that previous point to node next and node next previous point to node previous. Okay, so how do we? So we need to find if the character is already exists. Self the character dictionary the characters exist, then we need to find the node. And the node is dictionary the character. I mean the node to remove is a dictionary the character. We found it, so now we just apply this method to it. Remove node to remove. Okay, so else if oh, okay, after we remove the node, we have to update the dictionary because we saw this again. So self.dic. Oh, I forgot this self now. Self.dic character is now no. We want to remember the frequency, but we also want to remember the reference to the node. So for our dictionary, our value has two parts. We can use a tuple. Now to character 2. Let's see the first element in the tuple is the node's reference, and the second is its frequency. So here, we have to check our code again. next if next tail and node and add and rate and self that dictionary character 1 goes to 1. And we also have the dictionary point to this new node. And check the current dictionary. If character in the dictionary, then if the character's frequency equals 1, we put it out, remove, node to remove its character. So we need its reference. Okay, and then we remove node. And we want to update its frequency. Okay. So we remove this node and the frequency has changed. So now the character's reference to the node still point to the node, but the node is not in the stream, not in the non-repeating linked list anymore. Okay, it will be garbage collected later. We don't need to mind this. Okay, so next, if the of the dictionary, the character frequency, if it's more than 2, that means it is already been removed, so we don't do anything else. So that means it equals to 2. Not really. So, okay, so this is continue. We don't need to write this. We want to write this equal to condition. So if the character's frequency is equal to 2, that means it's already been put out. Right? Yeah. So if in dictionary, yeah, we should check if it's 1 or if it's 2, because after this update, it can be 2. If it's already 2, then we don't do anything. Let's continue. So if it's continue, we don't need to write anything here. Okay, so we need to check if character is not in dictionary. That means it's a new character. We need to add it into our dictionary. To add it into the dictionary, we should do 2 things. We should first add it to dictionary, and we also need to add it to linked list. Oh. So to add it in the dictionary, so the dic character equal to node. Which node? A new node. Okay, let's write it outside so we can use it. And the frequency is 1. And add it to the linked list. That means we should add it at the right. Oh. Oh, so we are repeating ourselves here. So this is the same thing. Okay. So we can delete this and move this here. So we check if the character is in the dictionary. If it's not in the dictionary, it also means it's not in the linked list. Yeah, so that is a else part. So means it's not in the linked list. Oh, how can I move it in the front a little bit? Never mind. So instead of one tab, I have 2 tab here. I don't know how to move it 1 tab forward, but it will work. 2 tab still works. It just looks weird. So if character is in the dictionary, we'll do this. Else, that means it's not in the dictionary. We should add it to the dictionary. And after we add it in the dictionary, we should also add it to the linked list. That is self dot at the right listening. Okay, we've added to the linked list now. What else should we do? Okay, I found a problem here because we want to update this frequency, and if I make it a tuple, then tuple is immutable, cannot change it. We can make it a list. Okay, now to make this function as we want. Okay, first let me try this shift tab. Okay, works. Okay, now we want to let's do this again. Shift tab. Print reading character from string. And after we've done this, if we want to, we will need to print the first non-repeating character. So is so far is a result. When you get this result, if the W linked list is empty, which means if the head next equals to tail, that means we have no content in this W linked list. We should return -1. So it's -1. And else we should pop the left item, not pop, pick the first item in our linked list. So result equals to self.head.next. So that is a node, and we need the character in the node. Okay, that's it. Okay. Like I have another idea. If we don't do this, if we don't store the frequency in the dictionary, we can also store the frequency in the node. For example, we can write another attribute called frequency, and it's default to 1. So let me change this code. I mean, the old version works, but I just want to try to make it in the node. Well, I won't try, but I think it will work. So I can draw something here. Let's draw it here. So what I have now is I have a dictionary, and I have key and value, and the key is just characters, and the value point to the value is a list. So the first one is a node, so it means it is a reference to a node to the W linked list. And the second item is a frequency. So, we can also just make the frequency inside the node. It might seems cleaner. So still character, and we have only one thing here is the node. So that is a reference to our node. But our node has, besides the previous and the next, we will have two things. The first thing is a character, and the second thing is a frequency. So we can modify this frequency. We can modify this frequency if we see a node, we see a character the second time, for example, that we can default this frequency to 1. And if we saw it in the dictionary already and we check the frequency is 1, then we want to update it to 2. And the next time, so after we update it to 2, this node is out of this linked list because we will remove it. But it is still alive. It's out of this dictionary. For example, we put it somewhere here. So it means it just lost its reference from the previous node and the next node. But if we still have this key value and this pointer to this node, then this node still is alive. It will not be garbage collected. So when we want to check frequency, we can still refer to the character, and the character find the node, and we can find the frequency in the node. So let me write this version because I can just copy the entire thing and write it on the side, and we can compare which one looks cleaner. So we will have that frequency equals 1. So this is our default value. If the node exists, it means it's already happened once. Okay, so instead of map character to this list, we just need to map it to the node. Just want to show I'm still recording. It's a very long video. Okay, and now so this should be the same, and we just to modify here. Check the character in dictionary. If character in this dictionary, they want if